Hi everyone, welcome back to Cody's Lab. So today I'm going to be refining quite a bit of gold jewelry. I guess I got tired of refining tiny little bits of gold. Basically over this last probably 6 months or so I've been kind of sniping eBay auctions for good deals on used scrap gold jewelry, and I've been buying it up. I think I've got at least $10,000 worth of gold jewelry here, so yeah, this is going to be interesting. I have a little card here which I've written down all the weights and everything for my stock that I currently have. Looks like I've got about 11.73 ounce troy of gold currently on this table. So that's pretty good. So this is the 18 karat, a little piece of 12 karat, got a whole bowl of 14 karat stuff, a bunch of 10 karat gold rings, and of course the little bits of gold that I've been refining throughout my YouTube career. I've got roughly 2 troy ounces here. So this is the stuff I used in my bullet video. That's what I hammered out in my silver play button video. And these other things here. This came with some of the other stuff that I bought on eBay. These little tiny beads are things that I've refined, the little itty bitty things. And I got a couple of 1 gram gold bars that Ave sent me, so I guess I'll throw those into the mix. I think I'm actually going to refine these separately because as they are, they'll dissolve in the acid right now, right? This stuff over here I will have to treat differently. Anything between 6 and 18 karat is insoluble in either nitric or aquariga. So in order to remove the silver, I'm going to have to add more. I put out a video explaining this earlier today. I'll put a link in the description so you guys can go watch it. And so to hit 2 birds with 1 stone, I've got a bunch of sterling silver here. I'm going to use this for the inquartation. This is about 90% silver, the rest being copper. But I'll mix that with the gold and that'll make it much easier to dissolve. My little card here, I figured, I need 700 grams of silver or copper to inquart the jewelry that I've got right there. And I think I've got about 1 kilogram of silver stuff, so I think I've got plenty to do it. So let's get one last good look at all the jewelry I'm about to destroy. Alright, here goes. Oh wow, it barely fit. And it goes. Alright, well that's melting. Let's go get this dissolving. To dissolve this amount of gold, I'm going to need roughly 100 milliliters of hydrochloric acid, which I'll throw in now. There should be little to no reaction. Now to this, to get the gold to dissolve, I'm going to have to use a strong oxidizer. For that I'll use nitric acid. I'm just going to add it in a little at a time so that it doesn't get all consumed with side reactions. We should need around 30 milliliters of this for this quantity of gold. So what's happening here is the nitric acid is oxidizing the gold because it's such a strong oxidizer it's able to do that. And the hydrochloric acid, which is all over in solution, the chlorine ions, they attack the oxidized gold, forming chloroauric acid, and that carries it away so that more nitric acid can react with the fresh gold. You can actually see that the gold has been etched. See, the crystal boundaries are now visible as the metal is being removed. You got this little bead over here which is turned dark. This is the bead that came out of the mercury. I think what actually happened there is I used an old crucible and it must have had a little bit of silver or something in it. It looks like it is dissolving, just more slowly. Oh my, wow, look at that. So this bullet's been dissolving in the acid for a little over an hour now. You can see those huge crystals getting exposed. So I've weighed out the 700 grams required. Let's open this back up. Looks like our gold's melted. You can see it down in there, a little bit of dross. Certainly a much smaller volume. Let's start putting in the silver. Here goes a silver spoon. Goodbye, spoon. Ah, that's lovely. Let's poke it down with another one. See, I peeled open this little heart thing to make sure there wasn't anything in there, like moisture or oil. So let's throw it in so it was clear. That's the last of it. Let's stir in just a couple of extra spoons just to make sure I've got enough. Give it a little stir while I do it. Oh, that's awesome. All right, let's let that come up to temperature again. And we'll pour it out. I'm going to be pouring it into this bucket of cold water. That way it breaks up into little tiny pieces, so make it faster to dissolve in the acid. Alright, here goes. Mix. Okay. Okay, so here's the material all turned to shot. You can see when it hit the water it kind of splattered. Increase the surface area so the acid can get at it more quickly. As you can see, I've got the silver and gold alloy spread out inside of this large jar. That's to help minimize losses due to frothing or whatever. And I have here some red fuming nitric acid. This is what I'll be using to dissolve the silver. The gold should be left behind. So I'm going to dilute the acid with a little bit of distilled water, right there. This is to help dissolve the silver nitrate better and also slow down the reaction rate. You actually don't want the reaction to going very fast. You can also see I'm adding the acid in small increments. So here we go, add the acid. It's pretty cold out here, as evidenced by the snowing, but I've got it on this hot plate, so it should warm up a little bit and the reaction will proceed at a more appreciable rate. Now we got a reaction going. See, if I tip this over a little bit, you can see the metal has turned a brownish color as the gold particles are forming on the surface. Those are insoluble. The gas that's coming off this should be nitrogen dioxide, otherwise known as red death, hence why I'm doing this outside. A little bit is okay, but a lot can kill you because it forms nitric acid when it reacts with water. Which is why you want lots of good ventilation when you're working with this. One thing that you'll notice is that the gas that's coming off of this isn't actually red. It usually is, but since it's so cold out here right now, the nitrogen dioxide is formed into nitrogen tetroxide, which is clear. It's still just as toxic though. I'm just going to have to keep it warm with a pot of water. Looks like it needs another shot of acid. I'm running a bit low on nitric acid, so I decided to make some more. You can see I've got some nitric acid dripping down into that flask. Over here I have a solution containing potassium nitrate and sulfuric acid. And you see the nitric acid is boiling out. It's condensing on this condenser here. This is how I've been making most of my acid recently, by the way. So here's our 24 karat gold. As you can see, the bullet is still mostly there. I guess nobody should be surprised by that. You know, it's so thick it would take forever to dissolve. You can see that there's some either silver or lead sitting on the bottom of the beaker. So there was some contamination there. So anyway, let's pour off this liquid and recover the gold from it. So I'm just going to carefully pour this liquid off. being careful not to get any of that silver in there. Now I'll just rinse this with some distilled water so as to recover more of it. Let that settle out for a minute. To reduce the gold back to a metallic state, I'm just going to add some sodium metabisulfate, and that should precipitate some gold. Looks like it is working. You can see that dark color of the gold forming. And just slowly add this here. The sodium metabisulfate actually forms sulfur dioxide when it reacts with the hydrochloric acid. It's actually that sulfur dioxide that pulls the gold out of solution. Here's something I haven't been able to show before. You can actually see the detail of the top of the liquid. Some of the gold is forming at the surface, and you can see it actually has the metallic color. Oh, that's lovely. Here's what the beaker looks like side on. You can see the gold particles are slowly settling to the bottom. See some that has already settled out there. And here we are a few minutes later. You can see that the solution is just about clear. Everything's settled down on the bottom. That's our gold sponge. So you can see the solution is still colored, and the gold powder is reacting, forming bubbles, and the solution above it is getting darker. That's telling me that there is a little bit of nitric acid left, which is redissolving the gold. So to fix this problem, I'm going to add a little bit of a diesel exhaust fluid. Now that should neutralize the nitric acid. Okay. Give that a bit of a stir. Now I can add more sodium metabisulfate, and it should precipitate out the rest of the gold. See, that settled out much better this time. Looks like all the silver's dissolved finally. That took all night to do that. And now, I just wash the silver out. Add some hydrochloric and nitric acid, just like I did with the solid pieces of gold, and dissolve it. And any remaining silver, like if there was any trap between some gold particles, will remain behind. Mainly the difference between this and that is this gold is already very fine, and so the dissolution will take hours and not days. So here's the gold powder from the jewelry. I just got through drying it out in the furnace. Here's the gold from the 24 karat pieces that I dissolved. Let's add that in there as well. And while I'm at it, I may as well melt down this rest of this bullet. The furnace is up to temperature. Let's open it up. Looks like the gold's liquid. Let's pour it into that graphite mold. Looks like it's just about cooled down to cold enough that I can work with it. Just pop it out of the mold. No problems there. Look at that. Let me dunk it in some water and we'll go weigh it. Look at that, I got a little bit of sunlight to work with. So here's my bar. Set on the scale. Focus the camera, so 345 grams of gold. My goodness. That's definitely the biggest chunk of gold I've ever had in my possession. Let's see. I was expecting to get 11.73 ounce troy. Let's figure out what I actually got. So I should have gotten 364.8 grams. And I got 344. Alright, Future Cody here. So I thought that number was a bit low, so I actually just gone through and recovered all the little bits of gold that were left out of the main bar. There was some bits that were left in the crucible, some gold that hadn't dissolved completely in the nitric acid. You know, the carat was too high. You know, the liquid that I poured off, the silver nitrate and copper, that would carry over gold particles, and that's actually was a substantial amount there. And there was also a little piece of the silver gold alloy that I took out to show Kangen because it was an interesting shape, and I forgot to put it back in. So I've got all that reprocessed, and here's the gold that I was able to recover. Looks like I got an additional 12.69 grams. So that brings my total to 357 grams of gold that I recovered in this video. That still is about 7 grams less than I was expecting, but that is a discrepancy that is probably about what you'd expect. The carat value of the jewelry is not 100%. I'd like to refine it once again before I'd guarantee any sort of purity. It's probably at least 99% though. Alright, so I promised the water jet cutting guys that I'd let them cut a gold bar. So I'll take that down to them. I'll put a link in the description. You guys can go over and watch this being cut with a 60,000 PSI water jet. So hope to see you over there.
Yeah. Go.